All right, this slide has some review problems on it from the first section of Chapter 7. Number 12 says fill in the table below using your conversion ratios for degrees to radians. As a reminder, to convert from degrees to radians, we want to multiply by pi over 180. And simplify, you want to leave your answer as a fraction if possible. And then to go from radians to degrees, we want to multiply by 180 over pi. So let's start with all the degrees and convert those to radians. Starting with 255 degrees, multiply 255 by pi over 180. Reduce this fraction as much as possible. So look for common factors. Right away, I'm thinking 5 goes into 255 and 180. 5 goes into 255 51 times. 5 goes into 180 36 times. We can keep reducing this because 51 and 36 are both divisible by 3. 3 goes into 51 17 times. 3 goes into 36 12 times. So this is 17 pi over 12. That's as reduced as we can get. So in my table here, 17 pi over 12. Next, we'll do 720 degrees. 720 times pi over 180. 180 goes into 724 times. So 180 divided by 180 is 1. 720 divided by 180 is 4. This is 4 pi over 1, or just 4 pi. I'm going to skip to negative 20 degrees. I'm going to get all the degrees converted first. Negative 20 degrees times pi over 180. See, 20 goes into both of those numbers. 20 goes into 20 one time. 20 goes into 180 9 times. This is negative pi over 9. Make sure that you still have the negative. Okay. Next up is 36 degrees. 36 times pi over 180. 36 goes into 180 5 times. So this is pi over 5. Okay, next we'll do 175 degrees. 175 times pi over 180. See, 5 goes into both of those numbers. 175 divided by 5 is 35. 180 divided by 5 is 36. And we can't simplify further. 35 and 36 have no common factors. So this is just 35 pi over 36. Then 21 degrees times pi over 180. 3 goes into both of those numbers. 3 goes into 180 60 times. 3 goes into 21 7 times. Okay, can't simplify further. That's just 7 pi over 60. Now we'll go back and convert the radians given here to degrees, starting with 11 pi over 4. So now I'm multiplying by 180 over pi. So 11 pi over 4 times 180 over pi. These pi's cancel out. Pi divided by pi is 1. Okay, 4 and 180 are both divisible by 4. 4 goes into 4 one time. 4 goes into 180 45 times. So this is now just 11 times 45, which is 495. 495 degrees. 9 pi over 10 times 180 over pi. Those pi's cancel out. 10 goes into 10 once. 10 goes into 180 18 times. That's just 9 times 18, which is 162. So I'm adding that to my table, 162 degrees above the 9 pi over 10. Last but not least, we've got negative 5 over 12 pi. I'm going to write it as negative 5 pi over 12. That's what that means when the pi's on the side of the fraction. Times 180 over pi. Your pi's cancel out. 12 goes into 180 15 times. 12 goes into 12 once. So this is negative 5 times 15, which is negative 75. Negative 75 degrees. And that's everything. That's our whole table. Okay, next, number 13, find the angles that make the following equations true. So the sign of what angle or angles is equal to negative root 3 over 2. Let's look at our unit circle. Remember that all of the points here on the unit circle are just cosine theta, comma sine theta, where theta is the angle of rotation. So let's look for coordinate points where the y coordinate is negative root 3 over 2, and then that'll give us those angles. So I see one right here. Notice that y value is negative root 3 over 2, so that's sine. And then there's another one right over here. So those angles would be 4 pi over 3 and 5 pi over 3. Or 240 degrees, 300 degrees, if you wanted to write your answer in degrees. Either's fine. I'm going to write my answer in radians. Theta equals 4 pi over 3 or 5 pi over 3. Next, we'll look at part B. Cosine theta equals root 2 over 2, so same thing, but now looking at the x-coordinate. Where do we have coordinate points where the x-coordinate is root 2 over 2? I see one right here and right here. Okay, just positive root 2 over 2. Those angles are at 7 pi over 4 and pi over 4. You can write your answer in degrees if you want. I didn't specify here, so I'm just using radians. Okay, so there's number 13, all done. Lastly, number 14 asks us to find exact values for the following. So part A, cosine of 2 pi over 3. Let me erase some of the highlighted marks that I have. What we're going to do here is find the angle on the unit circle and then look at the correct coordinate. For cosine, you're looking at x. For sine, you're looking at y. So cosine 2 pi over 3. Let's go to 2 pi over 3. It's right here. We want the x coordinate because it's always cosine and then sine. So here, our cosine is negative 1/2. So for part A, cosine of 2 pi over 3 is equal to negative 1/2. Next, for sine 5 pi over 4, here's 5 pi over 4. the sign is that y-coordinate. In this case, it is negative root 2 over 2. Finally, cosine of 11 pi over 6. There's 11 pi over 6. The cosine would be that x-coordinate. So root 3 over 2. That is it for this slide.